We'll have a look at GZ curves now and see how they're affected, looking at 4 different changes. And the first one we're going to look at is if a vessel increases the beam. So what we're saying is we've got 2 identical vessels, weight wise, etc., but one has a larger beam than the other. So let's have a look at the curve. Well, if a beam increases, when we think about the formula to get our Km is Kb plus Bm. Kb of course is just half the draft, but Bm is inertia over volume, or Lb cubed over 12 times the volume. So if the breadth increases, then inevitably the Km is going to increase. So if the Km increases, therefore your GM increases. So let's have a look at the curve. So here's our initial curve here. There's our initial curve, okay? And there's our initial GM. So we draw a tangent to the curve up to 57.3 degrees, and there's our initial GM. Well, excuse me, the GM, as we've said, definitely increases. So we've started the curve higher up, and we've drawn the tangent, and you can see that we've increased the GM. What also happens with an increase in beam is that the deck edge immerses sooner. Therefore our deck edge immersion is going to decrease. So when we had a smaller beam, our deck edge immersed later. Now, because we've increased the beam, we're decreasing the deck edge immersion. Now what that means is that when the curve starts accelerating away, at the point of deck edge immersion, it starts to recurve. So with the initial curve, we're accelerating away, then recurving. Because the second curve recurves sooner, obviously initially you're going to have all this extra dynamic stability, but because it's recurved sooner, when it gets to the end here, you can see that there's very little difference at this angle here when it gets to cut the x-axis, the angle of heel axis. So definitely you have an increase in GM, that's absolutely definite, increase in GM, but you have a decrease in the deck edge immersion. Therefore, when the curve recurves, the gap is going to be very narrow here. So we're going to have increased dynamic stability, GZ will increase slightly, angle of GZ increase slightly, range of stability increases slightly, vanishing stability increases slightly, but there's an insignificant increase in our range of stability, as you can see there. So beam, increase in GM, decrease deck edge immersion. Now let's look at the freeboard. Well, with freeboard, the vessel is going to be higher out of the water, therefore the deck edge is going to immerse later. But the GM is not going to change. Just because your freeboard is increased, your GM is not going to change. So in this particular curve, there's our original curve. The GM is unchanged, but the angle of deck edge immersion on the first curve it occurs here, on the second curve it occurs later. So you can see the curve is accelerating away and then recurving. So it means from the original deck edge immersion up to that point of the original deck edge immersion, nothing changes underneath the curve. It's only at the point of the original curve's deck edge immersion that the curve starts to change and increase the dynamic stability. So up to this first point, nothing changes. It's only after that that you have this increase in the dynamic stability. And you can see on this curve, there's quite a large gap with the range of stability. Whereas with the BM, the increase was very minimal. With beam, increase minimal because the BM is increased and the KM is increased. With this one here, with freeboard, it's increased quite a lot, the range of stability. So GM remains the same, deck edge increases. With beam, GM increases and the beam deck edge immersion decreases. Now let's look at reducing free surface effect. Well, if we reduce free surface, we're making the stability of the vessel better. So if we make the stability of the vessel better, we're going to definitely increase the GM. So here's our original GZ curve, and there's the tangent for the GM. Because we've reduced the free surface, our GM has increased, therefore right from the point here our curve is increasing, and increases proportionally all the way. So with all this we've got increase dynamic stability, increased GM, GZ value increases, increased range of stability, but of course what doesn't change is the deck edge immersion. Because our freeboard hasn't changed, therefore our deck edge immersion remains the same, but everything else, as you can see, is increasing. So when we reduce free surface, the GM has to increase, the deck edge immersion doesn't change. And the last one, we're going to talk about shifting a weight transversely. Well, if we shift a weight transversely, we effectively have an angle of list. So here's our curve here. With this curve, this, if you like, this weight has been moved across. Weight was here, it's moved across here. G has moved to G1 off the centre line. Therefore, this distance here is represented here, G to G1. And here we have what we call a healing arm curve. And that, if we took that right to 90 degrees here, it would go to 0 at 90 degrees. Draw the line across, and at this point here, where it cuts the GZ curve, that's our angle of list. And the range of positive stability now has to be between the 2 points at which the curve is intersected by our healing arm curve. So that becomes our angle of vanishing stability, that becomes our angle of list, and of course that becomes our range of stability. So we've looked at 4 curves: increasing the beam, the freeboard, reducing free surface, and shifting a weight transversely. Now with the first 3, of course, if we were to decrease the beam, decrease the freeboard, increase the free surface, it's exactly the same curve, but we would just name them the opposite way. So that's how we would draw those 4, and they're the 4 fairly popular questions that come up to label sketches involving increases in beam, freeboard, problems involving free surface, reducing it or increasing it, and then of course an angle of less with shifting a weight transversely.